Let's instead think about the inductive step. For the inductive step, we start with an assumption. We assume that proofs up until length n are tautologically valid. And based on this assumption, we then need to show that if we extend such a proof by one line, then the resulting proof is tautologically valid too. Now, when we add a line to a proof, there are two possibilities of what we might be doing. We could be adding a premise to the proof, or we could infer a line by an application of one of our inference rules. So let's think about these two cases separately. First, suppose that we add a line to a proof, and this line is a premise. Now, every premise depends on only itself. When I make an assumption, that assumption does not depend on any other assumptions. So clearly, if I add an additional premise to the proof of a tautologically valid argument, the result, again, is the proof of a tautologically valid argument. Given that every valuation that makes all of the premises on which the additional line depends true also makes this additional line itself true. Given that, vacuously, premises do not depend on any other premises. So that's the first case, when we add a line to a proof and that line is a premise. Now, if on the other hand, our additional line is inferred by one of our 12 inference rules, the situation is a little more complicated. And I want to spend a little more time thinking about the inductive hypothesis, since it will play an important role in our proof. So we are assuming that proofs up until length n are proofs of tautologically valid arguments. To illustrate what that means, let's start with a related assumption. Suppose that proofs up until length 5 are proofs of tautologically valid arguments. That means, with regard to the example here on the whiteboard, that for each line in this proof, every valuation that makes all of the lines on which that line depends true also makes the line itself true. So let's go through a couple of examples. Line 1 is an assumption. It depends on only itself. So vacuously, every valuation that makes all premises on which this line depends true also makes the line itself true. So that's covered. Similarly, for line 2 again is an assumption. Assumptions depend on only themselves. So every line that makes all assumptions on which this line depend true also make line 2, the sentence F in line 2, true. Now, line 3 is a little more complicated. Line 3 contains the sentence G and H, and this sentence depends on two assumptions. The assumption that if F, then G and H, and the assumption that F. Since these two assumptions were introduced earlier in the proof. Now, according to our inductive hypothesis, or according to our supposition that this line is, that proofs up until length 5 are tautologically valid, this line is tautologically valid as well. And that means that every valuation that makes the premises in line 1 and 2 true also makes the sentence in line 3 true. Now, similarly, when you look at line 4 depends on the same two assumptions, the premise in line 1 and the premise in line 2. And according to our hypothesis, every valuation that makes both of these premises true also makes sentence G true. And then finally, if you look at the conclusion in line 5, if F then G, this conclusion depends on only the premise in line 1 of our proof, since the premise in line 2 was discharged when we closed the subproof. So if we assume that proofs up until length 5 are proofs of tautologically valid arguments, that means that every evaluation that makes line 1 true also makes our conclusion in line 5, if f, then g true. Okay, so that's what we are assuming in our inductive hypothesis. We are assuming that all proofs up until length n are proofs of tautologically valid arguments. And that means that up until line n, for each line in the proof, every evaluation that makes all the premises on which that line depends true also makes the line itself true. Now, we will use a special notation for abbreviating some of the things that I just said. So I will call the set of premises on which line n depends delta n. So if n is a line in your proof, then delta n is the set of premises on which line n depends. So for example, going back to our previous proof here, delta 5 is the set that includes only line 1. Delta 4 is the set that includes line 1 and line 2. And that's also delta 3. Delta 2 is just the set that includes only line 2. And delta 1 is the set that includes only line 1. So in general, delta n denotes the set of premises on which line n depends. Now let's put it all together to try to show that TFL is in fact sound. So suppose that proofs up until line n are proofs of tautologically valid arguments. That's our inductive hypothesis. And suppose we add a line to such a proof. And this line is justified by an application of conjunction introduction. That means that our proof looks like this. Say in line L of our proof, we have a sentence of the form A. And in line M of our proof, we have a sentence of the form B. And then in line n plus 1 of our proof, we have a conjunction of the form A and B, where this inference is justified by a correct application of conjunction introduction. Now we need to show that this line, n plus 1, is tautologically valid, meaning we need to prove that every valuation that makes delta n plus 1 true also makes the sentence in line n plus 1, namely A and B, true. So how can we show that? Well, let's first observe that delta L and delta M are included in delta n plus 1. That means that the premises on which line L depends and the premises on which line M depends are included in the set of premises on which line delta n plus 1 depends. Why is that? Well, the only way for this general statement that I just made to fail is if line L and M were in a subproof that is closed before we get to line n plus 1. But according to our restrictions and constraints on the proper use of subproofs, you cannot cite individual lines from within a subproof after that subproof has been closed. And so since line n plus 1 is justified by means of an application of conjunction introduction applied to lines L and M, we know that lines L and M are not within subproofs that are closed when we get to line n plus 1. And that means that delta L and delta M are included in delta n plus 1. Okay, that was a first important observation. Now let's think about what the inductive hypothesis tells us. We have assumed that proofs up until length n are proofs of tautologically valid arguments. And that means with regard to this proof that lines L and M are tautologically valid lines. So every valuation that makes delta L true also makes A in line L true, and every valuation that makes delta M true also makes B in line M true. That's the upshot or a consequence of our inductive hypothesis. Since proofs up until line length n are proofs of tautologically valid arguments, we can infer that whenever all premises in delta L are true, A is true, and whenever all premises in delta M are true, B is true. Okay, that's what the inductive hypothesis tells us. Now, since delta L and delta M are included in delta n plus 1, every valuation that makes delta n plus 1 true also makes delta L and delta M true. So delta n plus 1 is a set of sentences, delta L is a set of sentences, and delta M is a set of sentences. And delta L and delta M are included in delta n plus 1. And that means that whenever all sentences in delta n plus 1 are true, it follows that all sentences in delta L and delta M must be true as well. But we have just reasoned that whenever all sentences in delta L are true, sentence A must be true, and whenever all sentences in delta M are true, sentence B must be true. And so we can conclude that every valuation that makes all sentences in delta n plus 1 true is a valuation that makes both sentences A and B true. But then it follows by the characteristic truth table for conjunctions that every valuation that makes all sentences in delta n plus 1 true also makes the conjunction A and B true. Okay, so that completes one step in the soundness proof. We have shown that if proofs up until length n are proofs of tautologically valid arguments, and if we add another line to such a proof, the n plus first line, and that line is justified by conjunction elimination introduction, then the thus extended proof is a proof of a tautologically valid argument again. Now, to complete the soundness proof, we would need to look at all the other inference rules as well, but we are not going to do that in this lecture, and instead leave it as an exercise that we are going to talk about during our class meetings. Okay, what have we accomplished today? We have introduced several new proof theoretic concepts. In particular, we have introduced the concept of a theorem, and we have introduced two new symbols, the turnstile and the double turnstile. And then we started thinking about how truth tables relate to proofs. And we have discussed what's meant by soundness and what's meant by completeness. Now, TFL is in fact both sound and complete, and that means that the semantic concepts that we introduced earlier in the semester and the proof theoretic concepts that we introduced today are interchangeable. So given that TFL is both sound and complete, a sentence S is a tautology if and only if S is a theorem. And S is a contradiction if and only if we can construct a proof of bottom of a contradiction from sentence S used as premise. Furthermore, A and B are tautologically equivalent if and only if we can derive A from B and B from A. And finally, a sentence A is truth table contingent if and only if A is not a theorem and does not entail a contradiction. So in short, given that TFL is both sound and complete, these concepts can be used interchangeably.